In this quick video, I want to dig a little bit deeper into the data structures that are sort of used within mrTools to interact with the data and so on. So once again, I'm in the folder that we've been working on so far, the data set. You can see it's grown a little bit because we've done some additional analysis and so on. And you can see that the raw data files that were originally there, so the anatomy and the raw time series, are still there. And if you go and check on them, actually they remain untouched. So the motion comp and various other things have been created, derived from these original data sets. And you might think it's sort of quite tempting to load in these nifty files directly to find out what's in them or to load them or to work with them. But actually it turns out that one of the design philosophies of mrTools, so decisions that Justin Gardner and David Higg and various other people made, is that you don't really want to mess with the data files that are on disk directly, but sort of a much better way of working with this that's a little bit safer. Okay, and so in order to explain this, let me bring up this picture that I've created here. So, which is here. So let's imagine on the left-hand side here, right? So I've introduced this idea of groups where maybe a bunch of four-dimensional data scans are collected, right? So this is the raw data that you get off the scanner. Maybe we've done some motion compensation, which sort of makes another version of each of those scans. And so there's a way to go from this type of data, from raw data, into motion comp. Maybe you want to average a couple of those scans together, and that's something sometimes people want to do in order to prove temporal signal to noise and so on. You might have another group called averages, or another step that is often taken for doing analysis for event-related and so on, is you actually concatenate the scans together in a sort of a clever way, which we'll talk about at some point. So for each of those groups, you can imagine sort of performing an analysis, which then gets saved with the appropriate group to which the data belongs. So that's what these arrows here indicate, right? So you might take some data from the motion comp group. You might perform a population receptor field or classification analysis, and that data then gets saved back into this group. You could imagine doing this to the raw scans, right? If you're just interested in raw time series statistics of the raw data, you could do the same step and so on. Now, how do we interact with these data? How do we get it out of the storage? We don't really want to load in these files indirectly, but so in order to make things safe, what we're going to do is instead we're going to consider all of the thing here on the left, sort of a view of our data. And in order to get information out, we're going to use a special function, which is called a getter function, and its name is viewGet. So any kind of bit of information that you want to know about your data set, you don't go to a particular data file, but you ask with the function viewGet this particular view of your data to get the answer. Okay. If you do an analysis and you maybe change something about the data, again, you don't want to just change the original data files, but you use a viewSet function to update the data. So why is this useful? Well, in particular with the setting function, you could imagine that certain operations, if you're doing one analysis, might touch more than one data file, or you might have to save information in a couple of different places, and in this viewSet function, you can make sure that this gets safely resolved. Whereas if you roll your own code from scratch, you might forget that there's sort of other places where you have to update information. So this is a safe way to do this. With the viewGet, we can also do some error checking and so on as that's going on. Okay, so I'm going to switch to MATLAB now, and I will show you, I will load in the mrLoadRet window, and then we will actually get hold of a view of the data, and we'll store it in a variable. It's a struct, MATLAB struct, which is sort of a nested data structure that contains lots of information in various fields. And then after we've done that, we're going to try and query some aspect of the data using this viewGet function. Okay, I just want to show you that. So let me close this down. I am going to actually get help on mrLoadRet. So you can see what's there. Right, so it's a function. We just want to run mrLoadRet as a function. So actually, let me show you the workspace. So at the moment, the MATLAB workspace is empty, so nothing is there. I'm now going to type mrLoadRet. Right. So you can see there's a sort of a hint in the command line that there's some global variables being set up here as well, which make sure that we can actually access data from the command window as well as within the GUI. So sort of some nitty-gritty in here. And you can actually see that we get an answer back from mrLoadRet. So we could have captured that for now as well, but this is actually a view of the data. So it's a struct that gets returned, and it's got lots of different subfields. And in the supplementary information on the GitHub page, I'll explain some more of this and also try and unpack some of them here. Okay. If we now look at the workspace, you can't actually see the global variable that's associated with this mrLoadRet window here. It's sort of hidden from view at the moment. Okay. If you just want to interact with the data here, internally, mrTools, the mrLoadRet code is using view_get and view_set to get various bits of information, right? So for example, if you edit some aspect of the data here, say for example, you edit some information of the scan. Actually, this doesn't have an edit window, but you can change file names and so on. This would be using the view_set function to change the data and save that stuff out. If it also requires changing some aspect of the raw data files, that might also happen with these functions here. Okay. Now, in order to get the view itself, we're going to use this function called view_get. So if you just type help view_get, you get some information, some meta help on how to use view_get, right? So in general, we can give a number of the view, which I'll show you in a second, some aspect of the data we want to get hold of, right? So these are called the parameters. So for example, what is the current scan that we're considering? What is the current slice? What is the current orientation that we're thinking about? What's the analysis that's loaded up in the view and so on? We can get all of this information. And so here's some examples down here of how you could get different aspects of information. If you just type view_get on its own, then you get a huge amount of information, and it's sort of a self-documenting function. It shows you all the possible parameters that you can query from the view_get. Okay, and so I don't think there's any aspect of the data set that you can't query through this view_get function. Okay, so if you're tempted to load in a particular data file, double check that there's not a way to do this here, for example, in your scripts. Right? So how can we use this? So there's one specific case for getting the view itself. So let me just do help view_get. Actually, another useful thing is, if you know the parameter that you want to query, so in this case, I want to query a number that's associated with this particular window, the viewnum. If you have some information about that, if we type help view_get, you can also get help on a particular parameter. Okay, so for example, if I want to get help on the parameter, getting information about the parameter viewnum, I should type view_get these empty brackets because I'm not asking about a particular view that's loaded up. I could type viewnum and then help. Okay, so let's try that. So if I say view_get, give it an empty, I want information about the parameter viewnum, and I want this as help. I get the subset of information about that, of how I could be using this, anything that looks like viewnums. Okay, I think actually if you append a question mark, that also works. Actually, no, maybe it needs to be in a separate field. Okay, so instead of help, you can type a question mark. Okay, so if I returns an array containing the viewnum of every active view, right? So in most cases, you only have one view active, and it's a very good guess that the viewnum associated with this view is the number 1. But if you want to be absolutely sure that there's nothing else kicking around, you can actually use this version of view get to get the viewnum. So I'm just going to copy and paste that line here. And you can see I get the viewnum 1. Okay. Now, the next thing I want to do is, I don't just want to get the view number, I actually want to get the data structure that represents this view. Okay, so, and the parameter of interest for that is actually view. Okay, it's the view itself that I'm trying to get. Okay, so it seems like sort of it's a weird Munchausen thing where the viewGet function is pulling itself out of the mud by querying itself, right? But that's sort of possible. So what I'm going to do is I'm going to ask for a particular view, knowing that the viewnum that I want to use is number 1. Okay. So let me just do home here so we can do that. Now, you might be tempted to store the result in a variable called view, but actually view is a MATLAB function. So it's generally good practice to just use v or some other kind of variable. But in most scripts and functions inside mrTools, v means the view that you're working with. We want to do view get. We don't actually have a view that we're working with at the moment, right? So I want to get view. Sorry, it needs to be the name view, and I want to get the current view, which is number 1. Okay, and if I do that, I get a structure back that contains all different aspects of the view. Okay, and I can now use this variable v to query other parameters about this particular data structure. Okay, so if I want to find out what is the current scan that we're considering, then I can say view get. I'm now using the actual view that I got, right? Because that's the object that I want to interact with, and I want to get the current scan. That's number 1. Just a little thing here. If you actually do all minuscules, it doesn't care about capitalization. So I think that's a decision that Justin made when he implemented this function, that you can't rely on people getting the capitalization correct all the time, so that's fine. Let's say, let's do something a little bit more substantial, which is I want to get back some information about the analysis that was performed here. Okay, so I can do that by asking for the analysis that's present. Now, I know that that's possible, but if you are struggling to find out what the names are for all of these different parameters that you might consider asking for, you can just type view-get and actually try and look through all of the different parameters, right? So there's lots of them, but it's not actually that huge a list. You can get the analysis, you could get the names of the analysis, numbers, the parameters that are associated with it. And again, you can also look at the help, show you a little bit more detail about how to get help and also search the code base from within MATLAB in another video. Okay. In this case, let's just get all of the information about the analysis back. Okay, and so what I will do here is I want to store the results in a separate variable, right? So I'm going to call that A for analysis. I'll say view get. I will give it a variable v, which is the view, and I say I want to get the analysis. And really, we would have to specify which scan, which group, and so on we want to do this for. But implied assumption is that you are using the current scan and the current group that you're looking at the moment. Okay, so this will hopefully work. All right, and I get back an analysis. Now this analysis tells you about which function was used to create it, which group this was associated with. It shows you some other information which we'll unpack a little bit later. But one interesting aspect here is that it also stores the overlays. Okay, so that's a structure in itself. And where does this number 6 come from? Well, if we go back here, you can see that there's a mean, a median, a standard deviation, maximum frame difference, maximum median frame difference, and the mean divided by standard deviation. So that's 6. So for each of those overlays, there's an entry in one of these struct array. So if I want to look at the first one only, I can do this. And we are now looking at the mean map, various aspects that were set for the overlays, and we can actually get access to the data itself. Okay, so which is a cell array because there were 3 scans, and this contains the overlay maps. So this is something that's quite commonly used if you want to do some analysis. You maybe want to rely on a previously computed analysis and access the data in there. Okay, so this is one way in which you could do that. Use the analysis as a starting point. You can also get more directly using the view-get functions at some of those maps, but this is sort of a good illustration of how this works. Now I want to finish this short video. We'll do another one on some of the nitty-gritty, and I will show you at the end of this video a pointer to what to read up on, actually, to get much more detail and some suggestions for how to do scripting. So one thing I want to point out to you now, which is sort of a gotcha when you first get started with this, if I now change a parameter, so let's just look back at our view. Okay, so it says its current base is 1, so there's only one anatomy file loaded, so that's not surprising. The current group is 2. Well, that reflects the fact that we weren't in raw but in motion comp. The current scan was set to 1, okay, and so on and so forth. If I now change this, let me just ask you, do you think the view that we have will now reflect this change that I've made in the GUI? So just think about this. Maybe you want to pause the video at this point for a second. So we can try it out, right? So let's look at V again. Well, the current scan is still 1. Why is this? Because the time at which we actually queried the view to get it, we got a snapshot that was consistent with the view in the mrLoadRet window at the time when we asked the question. Okay, so these variables are not synced automatically between the workspace and so on. So if you wanted to get another up-to-date view after you've interacted with a GUI, then you'd have to go back and ask for the view. So we'd actually have to go v is equal to, we'd have to get the view again, and in this particular case, the current scan has now changed to 2. Okay, so make sure you don't get caught out by essentially asking questions from a stale view of your data. If you are mixing, scripting, and interacting with a GUI, then you have to make sure that the current view is always in sync with what's going on there. Okay. Now, just to show you, the link to this page is on the GitHub materials. And so what we're looking at here is there's a section on scripting on the mrTools. So if you go to the overview page, which is this one here, it shows you some of the programming conventions, and it outlines this idea of a view as a sort of core place for interacting with the data, right? So lots of material that I'm introducing actually comes straight from this page, so that's good here. And then the other thing that's useful is there's some examples of how you could use this scripting to, if you collected a data set, say across 5 participants, and the data is all acquired in the same way, the data files are all very similar, it's just the names are changing, then rather than doing these analyses by hand, you could actually write a script that will do them for you. And so this gives you a walkthrough of how you could achieve that. Okay, so all scripting from the beginning to the end. All right, I'll stop here, and I'll pick up in the next video on some more details on how to do this and start walking through some examples of how we can interact with the views in sort of an interactive setting.